kind of funny. Anyway, moving on. It is warm. Good morning, everybody. It is another Tuesday and another day at university with Sarah. Yeah, it's pretty hot today. It's like not even 9, nearly 9. Or may have just gone 9. And it's probably about 23 to 4 degrees. Heading up to 37. How you going, England? You cold? I bet you are. And I bet you're jelly now. Anyway, we're going to go and look at the two systems that I've decided to categorize most of this project into. Some skateboarders over there. Longboarders, in fact. And, while Sarah goes to maths. And we'll split them into the electrical and the mechanical component system. Cool. Okay, hey guys, how are we going? This is getting complicated. I've been fiddling with this, trying to show you a easy to understand and visible version of the system diagram, or kind of like a layout, I suppose you could say. And this is the best I've come up with. Ta-da! When that focuses, that should look pretty good. Okay, so what have I got so far? Well, this is the mechanical system. It shows basically the mechanical components that fit together, not the electrical ones so far. We've got the deck at the top here in black, and then we go through all the different components from the nuts and bolts down to the hub and inner tubes. This is kind of like from one side only, so there's other sides, and there's obviously going to be 4 wheels on the skateboard, but if we were looking from the side on and we exploded all the parts out, this is kind of what we get with the mechanical system. So the truck's attached to the deck, and that's held there with nuts and bolts. The motor mount attaches to the truck. It's really it's very special it's very specific how the motor mount fixes to the trucks. There's a shape on this specific type of truck, caliber trucks, that the motor mount has been designed to take advantage of, and that shape it clamps to. So if that was different or smaller or bigger, obviously the motor mount would not fit properly, it would either fall off or wouldn't go on initially. So after that we've got the gears and the belt. These will actually attach onto the motor and the hub, but they are affixed over the top of the motor mount. I'd like to point out that it is a belt and gear system rather than a rack and pinion system, as I said before. Thanks Danny for picking that up. After that, obviously we've got the motor. The motor actually fixes directly to the motor mount, and the gear goes on the spindle of the motor, which will be obviously in the center. Outside of the motor we've got 3 cables coming out: power, positive and negative, red and black, and also the sensor cable. So these are brushless sensored motors, and that means that the electronic speed controller, and we'll go into that with the electronic system, can know, or it can tell whereabouts the motor is in relation to its spindle, because if it doesn't know and it just sticks power straight in, usually hop start, similar to manual gear stick or gear changes in a car. After that, of course, we've got the tyre and hub and inner tube. They're already put together in one component, and they basically just go straight onto the trucks, and then they have a large gear attached to them, so that when the motor spins really fast, for every single turn of the small gear, there's not a full turn for the big gear, so we gear that down to get more torque and less speed. Okay, the only other thing I wanted to really point out with this is that if you look up the top right here, you can see the deck, which I've shaded in with the diagonal lines, the truck in purple, and the wheel. Now, this is a bit more of a relative scale. The wheels are pretty big compared to the deck, and you should also be able to see that the truck isn't as low as it is on the other side over there. Right? The truck plate is attached to the top, and on this deck, and the way we do this is with a deck that's got drop-through fittings. So basically, rather than having just 4 holes for the bolts to go through, 1, 2, and then on the other side 3, 4, we've got a slot, and so the whole truck can slot through and then be bolted from the bottom upwards. This means that the trucks are a lot higher, and with the massive 9-inch wheels that I've got, this will be really helpful because it will lower my centre of balance and obviously make it easier for me to stay on the board with that. Otherwise, I'd be a lot more likely to come off. Alright, let's move on to the electronic system. Okay, the electronic system. Now, the electronic system works mainly off the fact that we've got an ESC, electronic speed controller, central, and holding this whole system together. It's kind of like the hub, the heart of this whole electronic system. So, the electronic speed controller controls the speed via electronics, basically, is the easiest way to describe it, and you'll have to bear with the shaky camera. The ESC obviously needs power, so it gets its power from a battery. In this case, I've got an 8-cell LiPo, and that connects through a positive and a negative cable to the ESC. Now, the negative cable will also go through a switch, which will allow me to turn off the power to the whole board. Basically, it will turn off power to everything, and then I won't lose any power from it just kind of sucking it through the ESC, even if I'm not running it. It's got to check that I'm not pressing any triggers, or it's not trying to move or anything like that. It'll be disconnected, which will be really handy. Right. After that, obviously, the ESC needs to get a signal. Now, the signal it gets, in the case of this board, initially will probably be a manual connection, but this is for kind of like the end goal. It should get a radio-controlled signal. So over the radio waves, an RC signal. You'll get that probably from a tiny little RC controller that I'll hold on my person. That'll transmit the signal, obviously, in an area, but I'll be standing on the board, so it should be picked up, and it will translate that signal into the amount of power it needs to put through into the motors, obviously, for speed. So at the bottom here we've got 3 cables, and the three cables signify positive and negative again. So we've got black and red, and it also has a third one, which is the balance cable, which I think I mentioned in the mechanical system. Now, it's really important to have that. Sensor cable, because obviously the electronic speed controller basically has the capability, and so do the motors, to know where they are in position to each other. So inside the motor, you've got your hub and the spindle. So effectively, the spindle at the bottom here, right, rotates inside the actual motor casing, the hub, which is where the power goes in. The 2 cables go in. Now, if this spindle, is the pen, and it's been rotated ever so slightly, say, out of sync with the motor, say, the table or the piece of paper here, and you just apply power, it'll snap into place, but by snapping into place, it's obviously going to jump. It's going to go and then it will run nice and smoothly. So, because it's censored, basically that allows the ESC to know where the motor spindle is, and therefore put the power in hopefully the exactly right amount to reduce that jumping, the jump start motion, because obviously that's not very pleasant. Apart from that, that's basically the whole of the electronic system. The only other thing that probably may go into here, out of the ESC, is the programming cable. So that goes all the way, to the PC. And the other thing that I would quite like to do is run a couple of extra cables off the battery, and possibly, or maybe even get a second battery, and I probably will have to do this just to increase the range of my machine here, to some sound systems, or maybe LED lighting, who knows, something fun like that, I reckon. Okay, cool. Hopefully you've learned a little bit about the electronic system, and that'll make it all a bit more kind of easy to understand when I go through things later on.